Hello everyone, welcome to another video by the YouTube Lab of Everything. Today we will be doing from science. So we'll be doing the second chapter, Is Matter Around Us Pure? I have actually done the first chapter from the same book, which is Matter in Our Surroundings. I will link it in the description and I will link it in the above there too. So let's get started with the video. Also, the notes for this chapter will be given in the description box below. First, let's discuss this question. What do we mean by the word pure? So, scientists, when you ask the scientist, any scientist, what pure means, he would say that a substance which has the same particles. So, like if he takes an example, gold. So gold has only gold atoms, no any other atoms. Silver has only silver atoms. If you mix an alloy with it, it's no longer pure for the scientist. Let's take salt. Salt is also a pure substance. It only consists of sodium and chloride together, which is a compound. So it only contains those compounds, no other compounds or elements. So we can say the salt is pure too. So that's how you can define pure according to a scientist. And that's how we'll be taking the word pure in this chapter as well. Now let's go for the word mixture. What do you mean by a mixture? Mixtures are constituted by more than one kind of pure matter. We know that when sodium chloride is dissolved, it cannot be separated. It can be separated from water by the physical processes of evaporation. However, sodium chloride itself is a pure substance and cannot be separated by physical process into its chemical constituents. Similarly, sugar. Now let's talk about a soft drink. A soft drink is a mixture because it contains carbon dioxide and soda and water. So it does not contain the same substance. It's all a different substance with different constituents. Wait, yeah. So for example of a mixture, as I just said, so soft drinks or air, water, there are so many kinds of examples for a mixture. Next, we'll move on to types of mixtures. So we can say that there are two types of mixtures: homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures are mixtures which has a uniform composition throughout. So for example, water containing copper sulfate, or water containing copper sulfate could be an example of homogeneous mixture or homogeneous solution, because it has the same constituents throughout. Now let's talk about heterogeneous mixtures. They have non-uniform compounds throughout. So that could be water mixed with copper sulfate and potassium permanganate, or or copper sulfate mixed with common salt. So the water does not have the same constituents throughout, because the water is mixed with copper sulfate and potassium permanganate, or common salt. So it has different components, so it's called a heterogeneous mixture. Now let's talk about solutions. A simple definition of solution is a homogeneous mixture of two or more substances. It's given as the first line in paragraph 2.2 in page number 15 of your NCERT textbook. So it can be basically defined as a homogeneous mixture of two or more substances. So yeah, we all know what a homogeneous mixture is: a uniform composition throughout. So there are so many kinds of solutions we come across in our daily life, like lemonade, soda water, salt water, sugar solution. So those could be considered, they are considered as solutions. Usually we think of solution as a liquid that contains either solid, liquid, or gas dissolved in it. But we can also have solid solutions and gaseous solutions. Solid solutions are called alloys, and gaseous solutions is air. So, for example, an example of alloy is brass, which is a mixture of 70% copper and 30% zinc, and air is a mixture of all the constituents like 70 like 21% of oxygen and 78% of nitrogen. Now let's talk about the properties of solution. Solution is always a homogeneous mixture, and the particles of solution are smaller than 1 nanometer, which is 10 to the power minus 9 meters in diameter. So they cannot be seen by naked eyes, so they're very small particles. Because of their very small particle size, they do not scatter a beam of light passing through the solution, so no light can be the path of light cannot be visible through the solution. The solution of particles cannot be separated through the form by the form of filtration, and the solute particles do not settle down when left undisturbed. That is, a solution is stable. So, if the particles do not settle down when left undisturbed, that means the solution is stable. Let's talk about concentration of a solution. So, take 50 ml of water and take a spatula and put only one spatula of copper sulfate in it and mix it. Observe the color of it. If you want to take a picture of it or just remember it. And now you're going to add 3 more spatulas of copper sulfate into the water. Now what will happen to the color of the solution? The solution gets darker. That's the concentration. So you have increased the concentration of copper sulfate in the water. So so there are like two parts of a solution, which is a solvent and solute. Solvent is the liquid which you dissolve the solute in. Water is the universal solvent So there are various ways of expressing concentration of a solution. So the first one is mass by mass percentage of a solution. So this is the formula for mass by mass percentage of a solution. It is mass of solute over mass of solution into 100. Now let's talk about mass by volume percentage of a solution. That would be mass of solute divided by the volume of solution into 100. Volume by volume percentage is volume of a solute divided by volume of solution into 100. Now let's talk about suspension. So suspension is a heterogeneous mixture of two or more suspensions. Uh, Solids are dispersed in liquids are called suspension. So like a suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended in the throughout the bulk of the medium. Particles of suspension are visible to the naked eye. Like for example, when you pour sand into water, you can see the sand particles in the water, and also sand does not dissolve in water. And if you leave it for some time undisturbed, this you can see the sand getting settled down in the solution. Now let's talk about properties of suspensions, and then we'll move on to colloidal solutions. Now let's talk about properties of suspension. Suspension is a heterogeneous mixture. The particles of suspension can be seen by the naked eye. The particles of suspension scatter a beam of light passing through it, making the path of the light visible. You can try this experiment by pouring milk in a carton, a transparent carton, and putting a torch through it so you can see the light passing through. Make sure you mix water in the milk, so only then you can see the light passing through. Next is the particles settle down if the suspension is left undisturbed. Once the particles settle down, no longer scatter light, and the particles will not be the light beam will not be visible anymore. Please make note that when I said that when water mixed in milk shows the light beam of light, I did not mention that it is suspension. It is actually not a suspension. It is a colloidal solution, which we will talk about now. Now let's talk about colloidal solutions. A colloid or a colloidal solution is a mixture in which the substances are regularly suspended in a fluid. So when you pour milk or ink in water, it's a colloid solution or colloid. The particles of colloid are uniformly spread throughout the solution due to the relatively smaller size of particles as compared to that of a suspension. The mixture appears to be homogeneous, but actually a colloid is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with the naked eyes, but these visible particles can easily scatter a beam of light, of visible light as observed when you pass it through milk. This scattering of beam of light is called a Tyndall effect, named after the scientist who discovered it, Tyndall. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by particles of dust and smoke in the air. Now let's talk about the properties of a colloid. A colloid is a heterogeneous mixture, and the size of particles of colloid is too small to be seen with the naked eye. Colloids can scatter a beam of light passing through it and can make it visible. They do not settle down when it's left undisturbed, so colloids are stable, unlike suspensions. They cannot be separated from the mixture by the process of filtration, unlike suspension, which can be separated by the process of filtration. A special technique known as centrifugation can be used to separate a colloid. Now let's talk about physical and chemical changes. Physical and chemical changes. I've talked about physical and chemical changes somewhere else in the language of chemistry, so please check it out. So if you've already seen the video or you already know it, physical changes are the changes which are can be reversed, whereas chemical changes cannot be reversed. And physical changes are changes where the change happens in the physical form of the substance and no new substance is formed, whereas in chemical changes it happens in the chemical constituents of the substances and new substances are formed. So that's the basic gist of physical and chemical changes. Now let's talk about types of pure substances. So there are two types of pure substances, which are elements and compounds. Let's talk about elements first. Elements can be classified into metals and non-metals. Robert Boyle was the first scientist to use the term element in 1661. Anthony Laurent Lavoisier, from a French chemist, was first to establish an experimentally useful definition of an element. He defined an element as a basic form of matter and that cannot be broken down into simpler substances by chemical reactions. So let's talk about metals. Metals are usually lustrous, which means that they are shiny. They conduct heat and electricity. They are ductile, which means they can be drawn into wires. They are malleable, which means that they can be hammered into thin sheets. And they are sonorous, which means that they make a ringing sound when they are hit. Now let's talk about nonmetals. Nonmetals are non-lustrous, do not conduct heat and electricity. They're non-ductile. They cannot be drawn into wires. They cannot be made into sheets, or neither do they make ringing sound when they're hit. So that's about elements. Now let's move on to compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. That can be defined as a compound. There is a lot of difference between a mixture and a compound. Mixtures are elements or compounds just mixed together to form a mixture and no new compound is formed, whereas in compounds elements react to form new compounds. A mixture is a variable composition, but compounds are always in a fixed proportion. A mixture shows the properties of constituent substances, whereas a compounds show the new substances has totally different properties. The constituents can be separated fairly and easily by physical methods. Compounds can be separated only by chemical or electrochemical reactions. So that's it for today, guys. Make sure you like, share, and subscribe. Also, I have linked the videos. It should be on your screen by now, which I have told you, the matter in our surroundings part and the language of chemistry part 1, where I will be discussing about physical and chemical changes. It should be on your screen by now. Please check them out. That's all. Thank you. Bye. See you in our next video.